All right, so let's take a look at number 1. All right, so there is a 3-digit number. Right now, so if you have difficulty in perceiving or visualizing what's going on here, so just go ahead and think about there is a 3-digit number right here. Oops. Let me go ahead and make a nice rectangle. So so this is a 3-digit number. Okay, so we have 3 spaces right here. So you know the hundreds and tens and the units or the ones. You know where they are. Okay. So we have these 3 slots, okay, and we want to figure out what these numbers are. And so let's go ahead and look at each. Yes. Oh, let me go ahead first, okay, and see if mine matches yours. So now what our job is to make sure that we write down the relationships. Okay, we write down the relationships based on the sentences. Now, so we have 3 slots. We need to first figure out what to represent each of these digits. What should we use? If we have X, Y, Z, all right? So we can simply say, oh, let's go ahead and say X is the hundreds, and Y is the tens, and Z is the ones. Now, sometimes we call it ones, sometimes we call it units. So they're both the same thing. So the 1. So we're saying, hey, there's an X, there's a Y, there's a Z. Okay, how many hundred, how many tens, and how many ones are there? So now let's go ahead and read the first sentence. And we say, oh, yeah, there's a 3-digit number, and the sum of all the digits is 11. So can you guess what is equal to 11? Louder. Yeah, X plus Y plus Z, it's 11. Okay, so don't make it too complicated. And then we say, all right, let's go ahead and take a look at the second sentence. If the ones digit is subtracted from the sum of the hundreds and the tens, the difference is 7. Do you know what is equal to 7? X plus Y, which is the sum of the hundreds and tens digit. And then we will subtract the ones from the sum. So that means X plus Y minus Z, it's equal to 7. That's so far so good. And then the tens digit is twice the ones digit. Now, this one could be a little bit challenging. And I want to spend a little moments to make sure that everyone is on the same page. The tens digit is twice the if the tens digit is twice of the ones digit. So now let me just go ahead and ask you this. If that's the case, which one is larger? The tens or the ones? If we say the tens digit is twice of the ones digit. Does it make sense that tens larger? Okay. Now, if you say, I still have a little bit trouble understanding this, that's very easy. I have twice the money of yours. Who's more wealthy? I do, because my money is twice of yours. So if you have $2, I will have $4, right? So now, and we try to portray this relationship into an equation. Now, make sure that you know it's equal. So we know that the tens digit is more, so this would not be valid, right? This would not be valid. Why it's not equal to Z? Someone has to multiply by 2 so that they're equal. So we multiply by 2, 2. Now, if you multiply the 2 to the Y, that actually is not okay, because the ones is already twice as big, and you now multiply the digit for Y, that it's going to make it bigger, and they are not equal. It should be 2z. Now that's a challenge. Okay, now just give you an example. Okay, hypothetically speaking. Okay, now look, our conclusion was what? The tens is bigger, right? So hypothetically speaking, let's imagine that the tens will be 6 and the ones will be 3, right? And we say, how can you make these two equal? Well, they're not equal. In order to make them equal, I would have to. Yes.
Wait, an easy way to see it would be like the tens digit, like under tens digit, you can put y, and then under is you could put equals to, and then to the.
You can do that too. Yeah, you can say this is y is choice of the z. That works. That's good. That's a good suggestion. But I'm just gonna say, all right, whenever you write an equation, you need to be a good judge to make sure that the left is indeed equal to the right-hand side. Okay. Now, in terms of today's task, our job is done. All we need to do is to write down all 3 equations. Okay. And what we could do is that, well, we can use a calculator to do it, and we can do it tomorrow, or we can do it by hand. And I do want to show you how to do it by hand. It's not that hard, but it's to practice the thought process. Earlier I said what? Earlier I said that back in middle school time, we only had to find x. It was a happy time, right? Last 2 weeks, we had to find x and y. We're a little bit sad because we have to reduce the number of variables through methods of elimination or substitution. The idea is still the same. We need to bring down the number of variables. Right now, altogether, we have 3. So now the question is, can we create a new system with only maybe 2 variables? Is it possible? And we say, yeah, it is very possible because we've got this. And why is this so tempting? Because, yeah, we can do substitution. This is y by itself. This is lovely. This is so, so lovely. So we can say x plus y plus z is equal to 11. We can say x plus y minus z is equal to 7. And we can just insert 2z into the place of y. That's called substitution. Because they're equal, so they allow, then you are having the power to substitute because of the equal. And now we're like, oh, so you have x plus 3z is equal to 11, and then x plus z is equal to 7. So now what you see here is that, well, earlier with the blue text right here that I wrote, the equations, there are 3 variables. They look disgusting to you probably, like, what is this? But now we're like, hey, it's not that bad because now we're seeing this, and this is just what we have seen for the past 2 weeks. And then we say, oh, how do you go from here? What do you want to do? Want to do substitution or elimination right here? You want to do elimination? Would you like to eliminate x or z? Z? Okay, and how would you do it? Okay, you multiply this by -3. You can do that. So I'm going to rewrite the whole system. And if you say you are more than welcome to eliminate x, if you find x to be easier to eliminate, there's no judgment here. Whatever you prefer, just make sure that you do it carefully. And then you have this. So x is equal to 5. We're like, oh, we know this number. It's 500 and something. Well, 500 and what? Well, you now have the x. The next variable we can find out would be z. Then we're like, hey, let's look at this equation. That's easy, right? So x plus z is equal to 7. So x plus, no, I'm sorry, my bad. I mean, x plus z is equal to 7. And what is x? Oh, x is 5. Now, I want to make sure that we're practicing this all together. Now, I know procedurally, if you look at this, procedurally, when you look at this, you just do what? Subtract 5, right? Now, there's still people who would make a mistake over here. They, instead of subtracting 5, they would somehow add 5 to the other side. So let's change the way to think about this. Instead of doing this procedurally, let's do this conceptually. 5 plus something is equal to 7. What must this something be? 2. Oh, so we know it's 500 and something too. What is the 10th digit? Well, we know the z is now 2. And what's the 10th digit? Twice of that. So that means y is equal to 2 times 2, which is 4. So what's the 3-digit number? 542. So now again, today's task, it's really just writing equations. I'm giving you as a little bonus, okay? If you don't have a calculator, if something is not that difficult, you do have the knowledge and power to make this happen, okay? You do have the knowledge and power to make this happen. So just want to make sure that you are okay with the extending the idea and concept of substitution and elimination to a system with more than 2 variables, okay?